Hi, I'm Jacob Tyson.
And I'm Krishma Desai, and today Jacob is going to be talking about Boyle's gas law.
Robert Boyle was a 17th century scientist and one of the founders of modern chemistry. He was the first scientist to carry out an experiment in which one variable was dramatically changed to observe the impact on the other variable in order to create a law. Specifically, Boyle examined the relationship between pressure and volume of a gas. He used a J-shaped tube in which a certain volume of gas was trapped above a column of mercury. By adding additional mercury into the tube, Boyle was able to change the pressure of the gas. By doing this, he was able to see how changing the volume of a gas occupies affects its pressure. From his experiments, Boyle was able to establish an empirical relationship between volume and pressure of a gas, known as Boyle's law. It states that the volume of a fixed quantity of gas maintained at constant temperature is inversely proportional to the pressure. In other words, as one increases, the other decreases, and vice versa. Expressed mathematically, Boyle's law can be written as volume equals a constant times 1 divided by the pressure, or the pressure times the volume equals that constant. The value of the constant is dependent on the amount of gas in the system as well as the temperature. Boyle's law is concerned more with the relationship between volume and pressure at a constant temperature. Because volume and pressure of gases are inversely proportional, as the pressure of a sample increases, the volume decreases, and as the pressure decreases, the volume increases, which can be seen on this graph. Due to this law, there is a direct linear relationship when volume is plotted against 1 divided by the pressure. Effect on volume when pressure is changed. At a constant temperature, Boyle's law states that when the original pressure and volume are multiplied together, it equals the value of the new volume and pressure. In other words, P1 times V1 equals P2 times V2. When the volume of gas decreases, the pressure of the gas increases. Example 1. A container holds 500 milliliters of carbon dioxide gas at 20 degrees Celsius and 742 torr. What will be the volume of the carbon dioxide if the pressure is increased to 795 torr? The temperature remains constant, which means Boyle's law can be employed. The original pressure is 742 torr, and the original volume is 500 milliliters. When the pressure is increased to 795 torr, the new volume can be determined by plugging it into this equation. 742 torr times 500 milliliters equals 795 torr times the new volume. 371,000 equals 795 torr times the second volume. By dividing this value by 795 torr, the calculated new volume is approximately 467 milliliters using 3 significant figures. This shows that the volume decreased when the pressure was increased. Effect on pressure when volume is changed. Example 2. A balloon contains 7.2 liters of helium gas. The pressure is reduced to 2 atmospheres, and the balloon expands to occupy a volume of 25.1 liters. What was the initial pressure exerted on the balloon? Because the pressure was reduced, the volume increased. To calculate what the original pressure was, we must plug it into the equation. P1V1 equals P2V2. P1 times 7.2 liters equals 2 atmospheres times 25.1 liters. This means that the original pressure times 7.2 liters equals 50.2. By dividing this value of 50.2 by 7.20 liters, it can be calculated that the original pressure of the helium gas was 6.97 atmospheres using 3 significant figures. This shows that the original pressure was higher than the new pressure when the volume increased. We can employ Boyle's law in everyday life. Our bodies use this law every time we breathe. The volume of the lungs is controlled by the diaphragm, a muscle under the lungs, and the rib cage, which is able to expand and contract. When we inhale, our rib cage expands and our diaphragm moves down, as can be seen in this image. This causes our lungs to expand with air, which increases the volume. The atmospheric pressure brings air into the lungs until the pressure in the lungs is the same as the atmospheric pressure. In other words, as the volume of our lungs expands when we inhale, the pressure inside decreases. Exhalation is the reverse of this process, as can be seen here. The volume inside our lungs decreases and the pressure increases. In conclusion, pressure and volume have an inverse relationship. As pressure increases, volume decreases, and as pressure decreases, volume increases.